Okay, so we've talked about ionic bonding. This one is going to be on ionic nomenclature. So nomenclature is naming. So we're going to talk about how to name these ionic compounds.
A neutral atom is made up of an equal number of positively charged protons and negatively charged electrons. Protons in the nucleus of atoms rarely become free, but electrons have the ability to move, and it is the valence electrons, those electrons in the outer energy level, that move and give the element its chemical characteristics. When an atom loses an electron, or more than one electron, it becomes a positive ion, because it now has more positively charged protons than electrons. If an atom gains electrons, giving it more electrons than protons, it becomes a negatively charged ion. These ions then attract each other because of their opposite charges. The two elements do not merge, they lose or gain electrons. The periodic table predicts when this type of bond is likely to happen. Chlorine is in group 17, and all elements in this group need one more electron to fill their valence energy level. All elements in this group strongly attract electrons. They are said to be electronegative. Sodium is in group 1, and all elements in this group have only one electron in their valence energy level. These elements are electropositive, meaning that they are more likely to lose electrons. Sodium is an element with only one valence electron in its outer energy level. Chlorine is an element with one electron missing to complete its outer energy level and become stable. When these two elements come close together, there is a natural tendency for the lone valence electron of sodium to move to complete the valence energy level of chlorine. In the process, the two atoms become ions and form an ionic bond. As a result, each of the elements becomes more stable. The new compound formed is sodium chloride, a substance everyone knows as table salt. This relationship is common in chemistry and has given rise to the octet rule, which states that atoms tend to gain, lose, or share electrons in order to acquire a full set of valence electrons. When ions are close together, they assemble into a pattern. Negative and positive electrical charges attract each other. For example, in sodium chloride, or table salt, the sodium ions are surrounded by the chloride ions, which in turn are surrounded by the sodium ions, and so on. They are arranged in this way to maximize the electrical attraction among them. There are many examples of ionic bonds. Some, like calcium carbonate, involve more than two elements. Ionic compounds share a number of similar properties. They have high melting points and tend to be brittle. Most dissolve in water, which separates the ions and makes the water a good conductor of electricity.
Okay, so just a review on our ionic compounds there. And when we're naming, we're going to put the cation first, and the anion is going to go second. Mon means one, so these are all going to be one atom, so your monatomic ions. The cation will keep the name of the element, and the anion is going to change to "ide." So the first element in the name in the compound keeps its name. The second element in the compound, the ending is going to change to "ide." So nitrogen would become nitride. If you have multiple charges for an ion, you're going to use Roman numerals in the name. These are typically going to be your metals that form multiple charges. So iron, you can have an iron 2 or an iron 3. Poly means more than one, so these are going to be made of more than one atom. And they're going to be a group. So remember, we said you cannot change the subscript on these. The polyatomics are held together by covalent bonds, so you're going to have a covalent bond between this polyatomic group and then an ionic bond with another ion in the polyatomic group. Polyatomics usually end in "ite" or "ate", so phosphate, sulfite. The "ite" and "ate" indicates that there is oxygen present, so phosphate is PO4 -3. There's an oxygen attached to that phosphorus through covalent bonding. Ates are going to have one more oxygen than ites. So phosphate is PO4 -3, but phosphite is PO3 -3. So the charge is going to stay the same between the two, but the "ate" ending indicates that there's one more oxygen present than if it had an "ite" ending.